Good. Thank you. So welcome everyone for this Espoo Clean Heat webinar. I will talk today with Heikki Keskiväli from Fortum as well about our city development in Espoo, southern Finland, how we are making the whole city and especially the district heating carbon neutral by the end of this decade. Then from the organizers, Euroheat and Power, I got the task to go through some of the housekeeping items in the beginning. So this event is recorded. That's good to keep in mind. And then a few other things to notice here is that while you are not talking, mute your mic so that we keep the presentation loud and clear. And for the questions, we will have a some half an hour presentation altogether, and then we will stop and leave some time for the questions. But you are allowed to ask questions all the time during the presentation as well. So two ways to do it. You can either use the chat function or the conversation box right there, what you want to ask, and send it. And we try to follow that and stop and answer when we see that the questions are coming, or then just raise your hand by using the button in the toolbar below. So that's all. I think then we go into the Espoo Clean Heat, but before that, let's have a few words about the Fortum, the company we are working with Heikki. A few words about that one. As you can see, we have scale and competence and resources to really make a change, not only in Espoo, but also in a wider geographical area. If you look at the last year numbers, and now I have to mention for those who have not been following the Fortum news lately, that we have closed deals to get the ownership share in Uniper more than 70%, and now it's soon reported first time as a part of Fortum Group, Fortum Uniper Group, and these are the numbers from the last year. So combined comparable EBITDA more than 3 billion euros in our group, and as you can see, we have a lot of power generation assets, different types, gas, nuclear, hydropower, and some coal assets, which will be based on our strategy phased out over the time, which is the situation also here in Espoo, where our headquarters is located. So more info about Fortum from fortum.com for those who are interested. So I will not speak about the group numbers more than this. So then a few words about the Espoo Clean Heat. Here is a nice picture of the second largest city in Finland. As you can see, it has a lot of forest, a lot of green forest, and it's going to stay like this as well. And there in back, you can see also the Baltic Sea. And in this picture, we are roughly looking at the southwest direction. I'm heading the heating and cooling business in Finland, and as mentioned in the beginning, my name is Timo Piispa, and then the latter part of the presentation will be given by the Heikki Keskiväli. Heikki is working in my team, responsible for the strategic projects, which we have quite many at the moment to make Espoo clean and carbon neutral in coming years. Let's start with the puzzle. What is common for the following four? And now I have to say that even if I allowed to use the chat function and make the questions, please don't spoil it for everyone in the beginning if you already know, but let everybody to think what there will be and you will get the right answer in the end of the presentation by Heikki. So Netflix, plastic bag, outdoor air, and the toilet. There is something in common in those, and we will come back to that in the end of the presentation. But first, few words about the agenda for today. What is happening around us? And now I'm really focusing on issues which are partly European-wide, but my angle for this presentation is from the Nordic country perspective. So if you consider that some of the points which I say might not be relevant, especially in your market area, you may consider that to be normal and the situation in the Nordic countries, and make the comparison that maybe your country is coming to the same point someday, or maybe it's developing to the different direction. Few words about that, what is happening in a bigger scale, why we are doing things like we are, and then more exactly focusing to the issues, what we are going to do about it. That's the agenda for today. What is happening today? The public opinions, they change faster than the asset portfolios we are having in energy business. Before the coronavirus, so roughly a few months ago, this was very typical what we saw in the news media. People were really asking for the respect the earth, respect the environment, make the things sustainable, get out from coal burning and things like that. And as we who are working on the energy industry, we have been more used to the practice that we make assets for the decades. So once we invest something, that is made to last. In our group, we have assets which have been running, or especially on the hydropower side, close to 100 years. So that is the kind of DNA we are used to. And very often we see that especially the young people and the public opinion is changing faster than our asset portfolios can do. In Espoo, we are using at the moment coal, gas, biomass, some heat pumps with the sustainable electricity, and so on. And this all is made to change. Not necessarily exactly all, but major part of the production is to change in coming few years. So, and where are we targeting? Electricity-based heat production, that really makes sense. And how does this work now? Yeah, more than 50% of the EU final energy consumption is heating. And how we are today producing the heat or power in general, and I have to say in here before somebody having very technical background is saying that now we are not comparing apples to apples. That's correct. This is a little bit illustrative in that way. But anyway, if you compare the efficiencies of the different technologies, efficiency in a coal is in around 30 to 40%, gas to power goes close to 50%, combined heat and power close to 90%, which is the normal practice in Nordics these days for the heating networks. And then when we talk about the heat pumps, which is naturally producing or utilizing the electricity, we are talking about the efficiency in range of 300-500%, depending on the several factors like the temperature or the heat which it's pumping. So keeping that in mind when you hear what we are going to do here might help you to think why we have chosen the path to go from non-burning to going from the burning technologies to the non-burning technologies and utilizing mostly the excess heat with the help of the industrial-sized heat pumps. Then another important factor is coming visible in here. So wind and electricity-based heat production, they are a great match. This is the city of Espoo heat demand last year, how it realized. You can see that there is a fairly big difference with the peak days going in a last year. They were going close to 700 megawatt on a heat demand, and in past years we have seen even higher numbers, going close to 1,000 megawatt in demand. And then on the summertime we are only around 100 megawatt range, so there is easily almost 10 times higher demand in a peak season than we have in the summertime. But then when we illustrate the Nordic monthly wind production curve here, how it works in almost any Nordic wind park which is installed or under planning process, you see that it follows roughly the same curve. So it means that when we are having more and more sustainable wind generation in our system, it has a great match with the heat demand in the system. So once we are utilizing the electricity from the wind parks, for example, for the heat production, we are having a great market coupling example here where we are aiming to. So it means that what I have seen in many presentations recently European-wide is that the energy markets, meaning the heat, power, gas, and so on, they have to integrate more and more. And here we see one good example of that. So what we are going to do about it? Let's start from digitalization. This is one way to show our business process, starting from production, maintenance, distribution of heat through the underground pipelines to the customers who are in demand of heat. And when you think about this very traditional way, and this is not showing the fuels and other parts which are important to keep the production up and running today. But anyway, now just focusing on these ones, as already historically we have digitalized very much our fuel delivery processes, made them to be with the very limited storage capacities, more kind of just-in-time deliveries and so on. But when looking to this end-to-end optimization, traditionally we have been quite manual in our operations, and at the moment we are increasing the level of automation, taking our new production facilities to the remote operation mode so that we don't employ operational staff at the site, but we more have our operations in the one central location, which is also having our all market operations in the same place. So once we are utilizing gas, we are producing electricity, selling that one, or we are optimizing the heat distribution to the customer end, that all is done from the same physical location, not power plant by power plant or so on. Then on the maintenance side, we have, and a few words more about the remote operations. That development we started, I think it was in around 2017 when we launched our optimization program, which we call FRED. And that was the kind of kickoff for this all end-to-end optimization development. So we first built a optimization engine, and now on top of that, we are building these automation systems to make the operations remote and improving in several smaller steps the operations. But just to mention some sums in Espoo city network, where we are selling some 2.2 terawatt hours of heat and generating some 600 gigawatt hours of electricity. Implementing the optimization platform is giving us several millions of better results or benefits per year than we had earlier in our operations. So in a million scale benefits, we are talking only in this first phase. Then we have installed a lot of new sensors and methods for the maintenance, which gives us a better view on operations we have and helps us to be more proactive. With the different companies, we have been developing the load predictions. For example, here is one mentioned, the Myst AI from the Silicon Valley. So it's not only the Finnish companies and the partners close to our home base, but we are looking as global as we can for the best potential solutions for us to provide best competence available. And for example, from the Myst AI, we get today alternative demand predictions, which we compare with our own, and by doing that, improve our demand predictions about the heat for the next day on an hourly level, so that we can optimize our production and the distribution in the best possible way, which helps us also to make it more automated, as we know beforehand where we are going. And then on a customer end, all the time more measures are taken there, sensors are installed. We have been establishing new solutions to manage the environment inside the houses and the offices, so that we have also been able to make a new type of products and the services, like the demand flexibility, so we can utilize the capacity of them. Another example, before I have only a few slides left, so I will then let Heikki to talk more. But you might wonder why I have this kind of nice pictures from the space. But that's connected to some of our latest innovations.
Timo, yep. You might need to take control again. Timo, you may need to take control once again.
Okay. What can you see
because of the disconnection?
What can you see at the moment? Can you?
Now we can see the space.
Okay, thanks. So what I was saying, yeah, you might wonder why I do have this kind of nice picture from the space, but that relates to our new innovation. So we are measuring 0.1 Celsius degree differentials from space to identify leaks in our system. So this is the network map in some part of the Espoo city. You can see the district heating pipes, and then we see from these satellite pictures that if there is leaks in a heat network, and if you have a leak, that naturally means that you have to add some replace water, and you are losing some energy as well. So we are improving our network by this. Traditionally, this was done by people on the ground, and then in recent years it has been done from the helicopters by making a photography from there. But now we are a little bit more further away and taking this from the space. So then a few words about the Espoo city so that you can put everything in a scale.
Excuse me, can I ask one question?
Oh, yes, please.
To the previous slide, can you balance out these unbalances? Like theoretically, can you balance them out by using some sort of, like borehole thermal energy storages or?
In theory, yes, you can balance it, but in practice, if you remember the slide a little bit before, it's like when summer load is compared with the wintertime load, it's like 10 times more. So having the seasonal balancing is very complex because of the high energy amount you have to keep, and that requires maximum investments. So I don't see that feasible, and that's why we have invested more in a short-term balancing mechanisms. One of those is demand side flexibility, doing that in a digital manner, the balancing, and then another one is very traditional heat storage or the battery accumulator, which is practically a big amount of water in a tank, and the tank can be underground or over the surface type of installation. But the seasonal storage, it's normally would mean, for example, this kind of geothermal drilling or something. It really requires a lot of space and deep heat systems. But Heikki is going to talk a little bit more about that. We have also a geothermal project ongoing, very interesting one. I think the first in the world in this scale, where we are drilling down to 6.4 kilometer. So it doesn't require any heat pump, anything. So it's just a direct geothermal utilization. So I hope that was somehow answering your question, and let's talk more in a Q&A. Few words about the Espoo so that you can put our story in perspective. Espoo is the second largest city in Espoo, and here you can see the construction site of one roughly 50 to 60 megawatt heat unit, which is running on biomass. And there is on the same site also some pellet production around 80 megawatt. So the Espoo is already now awarded as the most sustainable city in Europe. I was muted for a while, but let's hope that you hear me again. So and some 280,000 residents living in Espoo. Espoo has a clear target from the city side. They aim to be carbon neutral by 2030. And today, district heating accounts for over 50% of the city's CO2 emissions. So we are a massive emitter in Espoo at the moment, and that's why it makes really a difference in a city, partly also on a national level when we are exiting coal latest by 25. So heat production capacity, we have some 1,380 megawatt, and annual heat production some 2.2 terawatt hours per year, and 0.6 terawatt hours of electricity is also generated in our production facilities in Espoo. And just to put to the scale, we have 230 megawatt of coal-fired heat units, which we use as a base load, which accounts for more than 50% of the production today, and that we are to change in the coming few years. And here you can see how the amount of the carbon neutral district heating in Espoo is developing. So we started this journey already few years back. In 2014, we were practically only CO2 emitting in production. 2 years back, 26% after installing the first heat pumps. Today, already, we are 40% CO2 neutral as we have implemented some new capacities. Next year, more heat pumps are coming online, and also the geothermal deep heat system starts to operate, and we are already 50% level. And when the coal-fired, the remaining one big coal-fired CHP is going to be decommissioned, then 85% CO2 neutral production, and by the end of the decade, we are in 95 to 100% CO2 neutral. That's where we are going, and now it's time for Heikki to talk a little bit about the projects. Heikki, please.
Very good. Thank you, Timo, and fantastic day also on my behalf. So Heikki Keskiväli is the name. We're not in the very beginning due to maybe some technical difficulties. Hopefully those are now behind us. And I am responsible of the strategic projects in our business unit of Heating and Cooling Finland. There's only a few minutes of presentation time left, but hopefully it is okay to use up some of the Q&A time for that, as we have still 17 more minutes to go. So I will be now walking through our concrete activities project by project, and please feel free to ask questions at any point in time. So we start with Kivenlahti bioheating plant. It was actually just commissioned in May this year, and at the same time we are now closing one of our coal units, Suomenoja 3 coal heat boiler here in Espoo. So from coal we changed to biofuels, carbon neutral production, roughly 58, so roughly 60 megawatts of heat production. So that's basically what has already happened. Then moving forward, we are in exciting partnership with another energy company, ST1, and they have been, just like Timo mentioned in his good introduction, that this is a very unique project, one of the first in the world in this depth. And basically we are committed in buying all the heat output that we get from this project. It can produce up to 40 megawatts of renewable heat from the ground heat, or heat in the ground, but it's roughly 20 to 40 megawatts. The project output when it is commissioned, expected early next year. And just to put this into context, it's easy to say how many kilometers deep it is, but just let's take a look at it in a context. So here we have a beautiful drawing of a ground, and then where we are used to flying when flying was still our normal way of living and doing business. That height is of course roughly 10 kilometers. So it's quite fantastic that we are doing the same magnitude going down to the crust of Earth. Of course, not using a drill like that, but still, just to give you a little bit of context, what kind of magnitudes we are talking about with this project. It's quite impressive, and very much looking forward for the actual results. In addition to geothermal, we also have a third heat pump unit in Suomenoja being built. It's 20 megawatts in addition to previous 40 megawatts that we already have, and it's utilizing both seawater but also wastewater as a continuous stream of heat, waste heat that can then be primed with heat pumps to a sufficient temperature that can be then used in our district heating network. And the commissioning is expected next year, and this will now take us then beyond 50% in carbon neutral share. So very exciting development also on this front. Next, very quickly, we are addressing few projects that are not yet in the investment decision phase, but they are running towards that. One is a large-scale portfolio of air-to-water heat pumps, also known as AWHP. So up to 150 megawatts of distributed heat generation across the city. It would be built out in phases, and the first projects are already in the pipeline. Of course, this is new technology, especially in this scale that we're talking about. So it's very dependent on the eventual technology expenses, how the pilots go and so forth, but also how the taxation in the country is developing. So all these things will have an impact on how big we'll eventually realize. But this is very exciting development and distributed in its nature. Then this is maybe something that I truly love this concept. So let's take wind power. You have that. It's the cheapest source of new build electricity in Finland. You put that into a data center, and that data center then generates excess heat that can be put into district heating network, and thus replacing coal. I think this is quite a fantastic narrative, one of the best one can have in this business. So that's exactly what we are developing also. So 100 megawatts of wind-powered data center could provide roughly 1/3 of our district heating demand without any CO2 emissions. So of course this is dependent on the interest of data center operators, how the tax treatment of heat pumps connected to district heating is evolving, and how the Finnish industry electricity tax is changing. We are hearing and seeing positive development on these fronts, but certainly regulators need to move in order to make things like this reality. And we're talking about several billion euros in the greatest extent if these were to realize. So very big opportunity, not only for the Nordics, but also Finland, and especially to Espoo and Kirkkonummi. Then we have an exciting project on the industrial waste heat process heat side. So there's a big industrial area called Kilpilahti, roughly 40 kilometers east from the capital area of Finland. There we have a consortium of multiple companies, Neste, Helen, Fortum, Borealis and Keravan Energia. And we are studying the possibility of bringing waste heat from these heavy industrial processes to the capital region. And it's quite a magnificent scale. Currently, roughly 1.1 gigawatts of heat is going into the sea from these processes. So by utilizing that, we could bring in 3 to 5 terawatt hours per year of heat, thus covering 25 to 40% of all the heat demand in the capital region. Alone, this one project could cut the whole country's emissions by 3 to 5%. So this is truly impressive, and in the billion euro scale when we talk about the indicative capital expenditure on this kind of a project. So of course also this project is heavily dependent on any available public funding, also the tax treatment that I have previously mentioned, and also the eventual results of feasibility study and also the negotiations between all the related companies. But truly exciting opportunity this as well. So we started with a riddle. What is common for these four? Netflix, plastic bag, outdoor air, and toilet. And now it's prime time to reveal the answer. So basically what we have just heard, these are all potential energy sources. Netflix, of course, relates to data centers. That's heat we can use. Plastic bags, that is one of the industrial processes that are related to plastics in Kilpilahti, also potential energy source. Then we have outdoor air, the air-to-water heat pumps, of course, relate to that. And then finally, we have toilets, so basically sewage water. That is also something that we are using for energy production. So very exciting stuff. And along the way, we are reducing not only costs but also emissions. So very exciting development. So that brings me to final point of the presentation. So if we look at the global energy consumption provided by IEA, so the authority in the business, we can see the primary energy consumption changed in terms of terawatt hours. We can see how much is that, and then we can see what is the waste heat, how much there is waste in that primary energy consumption. And then we end up with the final energy consumption. So what is the amount of energy that we actually end up using? So this waste heat, 50,000 terawatt hours alone, that amount of energy is more than globally we use for electricity. It's actually more than double. And the key here is when we talk about district heating is the only scalable way to actually make use of these low value energy sources. So that's very good to keep in mind, whether you are an expert in the business or you work with regulators or you are a regulator or politician yourself. This is something that is truly important to understand and reflect. And we have seen many examples of that during this presentation. So for the Q&A, apologies for running a little bit over time. I will leave this visualization of our strategy here, waiting if you have any questions, whether on the chat or by using your mic. But please, anyone with any questions to either Timo or me?
Well, I would like to continue the discussion with the seasonal storages.
Yes, please.
Sure.
Yeah. So you talked about the challenges there, but as I see, for example, in this slide you have the heat storages there. So go on with the challenges, and of course, if you see any potential usages on some like a decentralized ways, for example, to use them. I would like to hear your opinions on that.
Okay. If I start from the heat storages, and Heikki, you may add on anytime. But like I mentioned, we have heat storages already today in a different sizes. The and you have to always remember when talking about the storage that there is always energy, and then there is a time what the energy can be in a storage. So there is a different type of heat storages. One is what we have already in the buildings which we are heating, and that we are managing through the digital solutions for the demand flexibility, so that we have walls and we have all the facility around us, and that can be used as a heat storage in a short time frame, meaning that normally people are totally fine if the kind of targeted temperature is, for example, around 21 degrees indoors. And you can play around that figure, around 1 Celsius degree, and people don't notice. They don't feel uncomfortable or so when the temperature level is slightly changing over the time. So that is one which we can use. Then when coming closer to the production, we have distribution network, which is consisting a lot of energy. If you compare that to the Tesla batteries, I think our Espoo network is. Do you remember, Heikki, how many Tesla batteries we have in the Espoo network if you convert it in that one? Let's say 1,000.
I'll dig it up. I'll come back soon with an answer.
But it's in that range. And then we have a really like a heat storage which we have constructed for that purpose next to our biggest heat production station in Suomenoja site, and that is a traditional water heat accumulator, the big tank full of water which we can upload and download with the capacity of 200 megawatt. And then we have some geothermal geothermal facilities where it is possible to store energy over a longer period of time. And normally the geothermal systems are also used for that type of storing the energy, as they are during the summertime less used, and then that time potentially some of the heat is put to the underground storage, and they can then back during the winter time. But like mentioned earlier, personally, I haven't seen feasibility in a big scale seasonal storages which are loaded, let's say once or maximum twice in a year, and then downloaded during the winter time. And as they require massive capex investments, and also the energy what you can store is anyway quite small compared to the size of the system. But there is also this kind of initiatives nearby, like in Helsinki in Finland, where they are utilizing earlier oil storages, pumping in seawater during the summertime, and then using the energy content of that one during the winter time. But anyway, that would be empty in let's say roughly 2 days when utilized fully for the Helsinki district heating system. So even if you store for the full year or the season, you may end up in the situation that you can cover only 2 days of the production or so.
Yeah. Thanks.
Okay.
Commenting with few. So firstly about the storages that Timo was referring to, there is a link to a public document that you can access now in the chat. There's also multiple different questions that would be maybe good to access, but or go through. But still, addressing that question very quickly. So firstly, our district heating network has an inherent storage capacity. So 1 degree would equal 800 fuel charges of a Tesla. So maybe that's something unaddressed or underestimated with regards to district heating networks, how much storage capacity there is inherently there. So this kind of a momentum or inertia of some kind. And then maybe to continue with the Power to X development. So if you have heard our new CEO, Markus Rauramo, speak, or the strategy development of Uniper, you can see that Power to X is very strongly on the agenda. And when it comes to seasonal storage, it might be the case that Power to X or similar approaches will be the most feasible, flexible, and the easiest technically feasible, economically and technically most feasible approach going into the future. So maybe those are a few things to address. Just very quickly taking a few questions from the chat. So have you considered solar thermal? Why did you discard it? Maybe a quick answer there is when there's a lot of sun in Finland, we don't need heating. So technically and economically.
Can I comment on that a bit? Because this
covers
basically both the heat storage and the solar thermal. We did lately a calculation to a village project of 320 detached houses. This sort of like a geothermal B-test system that basically is loaded with solar thermal during summer. And this system for the 320 detached houses would have a diameter of 100 meters. So it can be, for example, built underneath the buildings and the parking lots and so forth. And that would have a capacity of 4 gigawatt hours. And it wasn't that massive of a capex investment. So I see there are possibilities with a decentralized ways of either storing the heat from the district heating network to be used whenever needed, or from the waste heat, or reducing the need of usage of the district heating by these ways. So after the webinar, I would love to have a discussion on this with you, but go on.
Sure. Our contact details can be gotten from the facilitators. Maybe checking at this point before moving forward from the organizers. How do you see the time time-wise?
You are still fine to go. You pick up some of the questions like on the biomass, how you guarantee that's the resources and the sustainability of it. That was asked from Gopi. And in line of it was a question as well from Antal Thompson. How do you plan to ensure that the biomass heating is carbon neutral within the Paris Agreement timeframes? I think that's something which came up quite early at the beginning, and you are happy to go.
Okay, thanks. Yeah. Do you want to?
If I start, and you may add on. So if I first take this sustainability issues, we have a strong commitment on the sustainability also on a biomass side. So we aim to buy all the biomass what we utilize based on the sustainability standards for the forest industry and the good use of the forest. So in that way, we are also utilizing mostly the biomass which is sourced from the local market or from the nearby countries. So for our assets in Espoo, we don't have any kind of very long-term biomass deliveries, but more from around the Baltic Sea. Let's put it in that way. And what comes to the sustainability of the biomass itself and the bio in heating, as you can see, we are more developing the non-burning solutions, meaning that the biomass for us is a kind of temporary solution to go to the carbon neutral. And our new investment plans, which you see in this strategy illustration, there is no new biomass plans in our plan. So there is one multi-fuel plant with the question mark in very end of this decade, but the aim is not to develop that one, but to more develop these geothermal heat solutions, heat pump, and the excess heat utilization based on the industrial excess heat or data centers or to that direction anyway. So biomass will have its time, but it's not going to be there for the heat production more than needed. It's a little bit like a coal. It will have an ending date, I would say.
Yeah, very good. Thank you, Timo. And to continue with a few of the questions, so there were questions about the CO2 emissions of the heat pumps, and basically we have given a lot of thought for that. And there is the benefit of contracting long-term renewable PPAs. Like mentioned in the beginning, wind power is the cheapest source of new build electricity in Finland, and there is no new feed to contract the electricity needed for long term. And certainly one might argue that wind is intermittent. That is, of course, correct observation, but we also have the benefit of owning a massive portfolio of hydro, of course, renewable as well. And the storage capacity there is we can provide the flexibility for renewable heat pump production. So basically the combination of the bulk wind energy and then coupled with potentially hydro to balance it out, certainly we would be then sure to have it CO2 free. Then going back to very quickly on the solar thermal question, so of course capex matters, that's one way to look at it, but then of course value of energy changes over time, so it's not enough to have cheap energy over the summer, so it has to be cheap during the winter, so that's also one consideration to have when formulating the full picture of the techno-economical feasibility. And then few words about a question of there was the cold weather and air-to-water heat pumps. So there's also a correct observation there that the coefficient factors will drop in the very cold temperatures. So that is certainly something that we are studying into, and that is also why we increase those volumes stepwise, so that we can learn how these pieces of equipment do operate in real-life environment and how we can optimize the use of those. And then certainly when we model our own production going forward, of course, we take that change into account. So certainly for the very cold periods, we then might rely on the incinerating technologies, but still carbon neutral. But then, of course, a lot of promise in the power-to-X technologies as a future development. So maybe we will have fully green synthetic gas, hydrogen or natural gas. Maximum flow temperature about our DH network. So I think it's very fairly basic. We also have some data on the on the internet. So maybe depending on the outdoor temperature, of course, but the typical variation that can be, I think our peer Helen has some open data on that available for anyone interested, but of course the very highest temperatures of 120 degrees are rarely needed nowadays. So the average temperature clearly lower than that nowadays. What else? Smartification and optimization of production. So maybe a few points there. Certainly, when we have smaller distributed units, they become much more flexible than these gigantic units that we are maybe previously accustomed to. So certainly that is a benefit on that. And then the end-to-end program that Timo described earlier. So certainly that is addressing those exact points. So in order to have more flexibility and more optimization in the system, we need to have more data about our environment, where all these measurements, of course, have an impact, but also the sensors about our own equipment and power plants and so forth. So there's a lot of development on that front, but it's still work in progress. But certainly many of the assets that we have today already have a certain amount of flexibility inherently in them. And then we have, of course, household solutions. Maybe Timo, if you could comment a little bit about how we execute the flexibility on the customer side. Would you, Timo, have maybe comments on that?
Yeah, I can say a few words on that one. So we don't, and I think there was a related question to hourly prices and so on, but just to clarify that point, we do have a hourly measurement of the heat demand and the heat utilization on the customer end, but we don't have hourly prices as there is no this kind of relevant heat market at the moment, and we don't see any benefit of establishing it. And we have seen it more beneficial for the customers also, that we provide more constant temperature, and we aim to provide as a service the conditions, not just the energy, meaning that when we utilize the sensor technology in customer premises, we are able to provide more constant set temperature to the targeted level, and we put that in our optimization system so that we are using the variation or the flexibility in the temperature in a way that it creates a short-term storage in the system. As in the Nordic power market, we have hourly prices for the electricity, and we optimize the whole system in this integrated energy market system, so that we take into account the electricity when we are buying it for the heat pumps or producing electricity, also the gas market parameters are taken into account, and then the heat demand, and we are able to manipulate the heat demand because we have these different storages, meaning the DSR, demand side response, as well in the same optimization system. Maybe that gives you a little bit of insight on that. But no hourly prices for the heat as such.
Yes, there is one interesting question on a hot topic today about competition to district heating in new built housing in Espoo with increasing use of individual heat pump solutions. So maybe a few points there. So certainly there is a lot of interest towards heat pump solutions, just like we see also good prospects for the industrial scale solutions. So firstly, of course, we believe, and it's fairly logical, that by having larger industrial scale units distributed across the network, executing on that kind of projects is unit-wise and production specific-wise more affordable than individual solutions. And then in addition to that, there is the security of supply, because you are not relying on one individual technological solution, but you actually can benefit from multiple units. So if things go wrong at the wrong time, then in that case there would be a better situation from the whole network of production assets. And then certainly maybe one thing that we have seen is that there are some rosy projections regarding the cost levels and the price levels, whether it is the technology per se or the prices of alternatives. So of course, if the buyer is not maybe the most sophisticated, or it is challenging otherwise to make realistic comparisons, of course that kind of outcome will end up in maybe not the money best spent, so to say. And we have already seen also some backlash from that development. So some housing associations are also seeing these negative impacts that were not there when the solutions were sold, and now they are coming back to reliable solution that district heating also is. So few things that we have observed so far. But the interest is there, not to say that, and heat pumps certainly as a technology are very interesting, and of course then carbon neutral done the right way.
Yeah, just summarizing what Heikki just said very shortly, I see that it's good to have a competition. It keeps us awake, and on the other hand, district heating is really a service. It is trending at the moment, also European-wide, that people don't want to invest on their own when it requires also having a lot of competence in organizing the maintenance and the operations and the backup systems and everything. So once you are connected with the district heating, that's all done by the heat provider or the service provider.
Yes, that's exactly true. And one thing with heat pumps is rarely they actually solve the whole problem. So even though you have individual heat pump, you still need the backup for peaking demand. So instead of one solution, housing associations usually go for two solutions. So that's interesting dynamics also in the space. So it's not techno-economically the best approach to have only the heat pump. It gets very expensive that way. So that's also one point. There was a question about exploring hydrogen storage. So yes, that was mentioned earlier, that especially with ours and Uniper's latest strategy points that we have made, hydrogen is most certainly very exciting opportunity, and part of that you can also put into natural gas network to have a mixture of synthetic gases. What else? It's now 1:01, so maybe again checking from the organizers, how do you see How do you see?
So I would suggest to slowly start closing it because people may have other meetings. If you take one last question and then be sure to everyone, we are recording this meeting and we'll make it as soon as possible available as well on the YouTube channel, and we'll follow up with Timo and Heikki on the questions which may have been unanswered during this time. Thank you.
Thank you. So what should we answer? There was something about the hydrogen I noticed earlier, but now I don't see it again. But anyway, if talking a few words about the hydrogen, in Fortum Uniper Group, we have some hydrogen installations, and we are studying these opportunities quite widely at the moment. How to store on a hydrogen, or how to even produce hydrogen in a way that the excess heat from the process is utilized by the district heating network. And there the logic is exactly the same, like Heikki was talking about the Kilpilahti. You have an industrial process which is needed for other purposes, and then with the large scale district heating network system, you are able to utilize the excess heat, so you are not wasting that part of the energy. From my side, I would like to thank you all for joining our webinar, and I'm very happy to see that there were so many people over the past hour joining us, and very active discussion on the chat. Thanks for that as well. And I really hope you very good summer. In Espoo, we have a coal-free summer for next 2 months. So our journey is proceeding in a way that we are having 5 times less emissions during this summer than we had during the last summer in 2019. So good progress in this, and looking very positively to the future. Thanks for everyone.
Thanks everyone. Have a good day.
Thank you. Bye-bye.
Thank you. Bye-bye.